Hi everybody, this is our first video back for a while and we're preparing for your quiz that's coming up tomorrow, April 16th, over these first 6 lessons in probability. Tonight you were to finish that review and to watch this video to check. Tomorrow you will take your quiz. We want to make sure that you understand the right answers and why they are correct. You'll remember that we went through in class today and we looked at the different lesson summaries for each lesson. And overall, you guys did pretty well until we got to lesson 6. And that's why we went over in class today your exit ticket for lesson 6. Had a little, still having some trouble with the probability of an event plus the probability of not the event, that complement adding up to 1. And I reminded you that there was a video that you were supposed to watch. So if you haven't done that, maybe something you want to do tonight. And then it was the tree diagrams. Remember that your stages are the columns, and then what can happen in each stage is what goes in each column. So for this one, Monday, this was that board game, card game example. Monday and Tuesday were the stages because we could play a board game or a card game on Monday. And then we had to match that board game on Monday to all the possibilities on Tuesday, which would be another board game or another card game to get the outcomes. We went over this exit ticket, and now we want to take a look at your review. Determine whether each event is impossible, unlikely, equally likely, likely, or certain for numbers 1 through 3. I wasn't specific here, but I was considering just a regular old die, a regular old 6-sided die, one that maybe looks like this. Nothing fancy, just a die. So if this wasn't what you were thinking about, then you may want to change these answers. The probability of rolling a 7 on this number cube is 0 out of 6. It is impossible. You will remember that probability ranges from 0 to 1. 0 is impossible, 1 is certain, halfway is equally likely, and depending on which way a halfway you are, will depend on whether it's unlikely or likely. 2 was flipping a coin and getting ahead. Probability for getting ahead is 1 possibility out of the 2, which makes it equally likely. Drawing a red marble from a bag with 7 blue marbles and 10 red marbles, so we've got 17 altogether. 10 of which are red, so the probability is 10 out of 17. That makes it likely. And then we get to number 2. This is one where I had to make some changes. So I highlighted that should say the sum of 4. If I didn't get that changed on yours, please make sure that you change it now. Charlie rolls 2 number cubes, and in this one we don't know what kind they are. What we know is that the probability the sum is less than 4 is 2 out of 21. And the probability of having a sum of 4 or greater is what you're looking for. Changed our mind, not doing the sample space because we don't know what the number cubes are. But, why does that say 1? That shouldn't say 1. The probability of less than 4 added to the probability of not less than 4 should equal 1. And when we talk about a sum of 4 or greater, those are all the numbers that are not less than 4. So you can find the probability of a sum of 4 or greater by starting with 1, subtracting 2 21sts. That'll give you 19 21sts. Remember that probability can be written as a decimal, or it could also be written as a percent. Okay, and that looks like it finishes out this page, and so we'll move on. Aha, covered up. Number 5, if Anna exercises for at least 45 minutes on the day she has to work, if it's Monday, that's a day she's got to work. 30 minutes is less than 45. So would we expect her to exercise for over 30 minutes on Monday? You betcha. Monday is a work day. We would expect her to exercise 45 minutes on a work day, and 45 minutes is over 30 minutes. 6. David made 16 out of 28 free throws at basketball practice. What is his estimated or experimental probability of making his next free throw? Okay, so the probability of making it would be 16 out of 28. That would reduce to 4 over 7. You could write it as a decimal, or you could write it as a percent. That looks like all of those. If you have any questions about these, when you come to class tomorrow, ask me the couple that you have trouble with so we can help you straighten it out. Number 7. Christina scored an A on 7 out of 10 math quizzes this quarter. What's the estimated experimental probability that she scores an A on her next math quiz? The probability of an A is 7 out of 10. She got 7 A's out of the 10 quizzes, which could be written as 7/10, which is the same thing as 70%. Number 8. For the past 2 weeks, Courtney has picked 9 long sleeve and 6 short sleeve shirts to wear to school. What's the probability that the next shirt she picks will be short sleeve? First of all, you need to add these together. 9 long sleeve and 6 short sleeves would give us 15 shirt possibilities. So if the first one we're supposed to do is short sleeves, then that would have to be 6 out of 15 because 6 of those 15 are short sleeve. It would reduce to 2/5. It's the same thing as 0.4. It's the same thing as 40%. Part B, probability that she's going to pick a long sleeve. Well, instead of 6 over 15, you'd have 9 over 15 because there's 9 long sleeve shirts. That would reduce to 3/5, which is the same thing as 6/10, which is the same thing as 60%. That finishes up that page. Number 9 may have been the one that was the most challenging for you because from what we had done in class, making this tree diagram was where you seemed to struggle the most. Chad has blue pants and a tan shirt. He also has a white shirt, a gray shirt, a blue shirt, and a yellow shirt. You are to find the sample space using a tree diagram. First, you need to think about the stages. What does he have to pick from? He can pick shirts and he can pick pants. Those need to be your 2 stages. Then we're going to finally come up with the outcomes at the end, and all of those outcomes together makes the sample space. So as far as pants go, he's got blue and tan. That blue shirt, that blue pants could be matched to a white shirt, a gray shirt, a blue shirt, and I think I forgot the yellow shirt. So I need to add in a yellow shirt right in here. Oh, no, it's got to go here. And then mine. All right, so now with those blue pants, they could be matched to a white shirt, a gray shirt, a blue shirt, or a yellow shirt, making the 4 outcomes that you see on the side. We would have to do the same thing with the tan pants, and we end up with 8 different outcomes. This is the sample space. All of these outcomes are the sample space. For number 10, we're doing pretty much the same thing, except this time our 2 stages are the ice cream and the toppings. So I'd list the ice creams. Well, that's not going to work because you can't see that. So with ice cream as our stage 1 and toppings as our stage 2, we've got vanilla, chocolate, and strawberry listed. Each one of those would then be matched to the different toppings. Fudge, I don't remember, C is, oh duh, caramel, and marshmallow cream. Got all of them matched that same way, which then will give us our 9 outcomes. This entire list of outcomes is your sample space. Beginning for 11 and 12, we're using a 12-sided number cube. I don't think I can find a picture of a 12-sided number cube, but that's the idea. And you're to find the probability of each event. So we've got the probability of even and the probability of greater than 10. I gave a suggestion to one young lady I know earlier to write all those numbers out so you have it to look at. So you should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. That's your sample space. So we've got 12 possibilities. Out of those, how many are even? Well, that would be 1/2. 6 out of 12 would reduce to 1 over 2. How many are greater than 10? Well, that's just 11 and 12. That would be 2 out of 12, which reduces to 1/6, which is the same thing as 16.6%. Looking at those numbers, we want to know the probability of less than 6. Well, there are 5 that are less than 6. So that probability is 5 out of 12, which equals 41.6%. The probability of 9 is 1/12. And the probability of not 9, you would start with 1, all the probabilities, subtract that 1/12, and we would have 11/12 to be the probability of not 9. That's the idea of that complement, the event and not an event. And if you haven't watched that video, you might want to. Lucy and her cousins are choosing some names. She's got 6 boy cousins and 7 girl cousins. If she's randomly picking her cousin's name, what's the probability she picks a girl, and how do you know? You are to explain it. Probability is going to be 7 out of 13. There are 13 cousins altogether, and 7 of those cousins are girls. So the probability would be 7 out of 13. The number of outcomes is 7, and the number of possibilities in the sample space is 13. That might be a little bit better way to word it, using some of that mathematical vocabulary. Oops. Come back here. Aha. So we're to make a prediction out of 250, how many times that Carrie would hit a home run if it's 14%. Setting up a proportion is the best way to do it. I'm sorry that those aren't lined up correctly, but I couldn't type it very quickly the other way. Once you solve that proportion, you'll find out that Carrie's going to hit a home run about 35 times out of her next 250 at-bats. And finally, Brian rolled a number cube 24 times, used for 17 and 18. Again, we are expecting, with nothing said there, we are expecting just a regular old die, 6-sided die. How many times can he expect to roll a 6? Well, there's 1 out of 6 on the die, so we'd want to make a prediction of how many 6s out of 24 rolls. And you should expect Brian to get one 4 times. How many times can you expect Brian to roll a number less than 4? Well, the numbers on the die that are less than 4 are 1, 2, 3. 3 out of 6. We want to know how many out of 24, so x over 24, and we would expect that to happen 12 times. So that finishes up everything. Your quiz will be tomorrow. If you had any trouble with that, please ask me a question when I see you tomorrow. Good luck. Have a good night's sleep. I'll see you then.